For decades, killer robots were just stuff you saw in the movies, right? Science fiction. Well, that's not the case anymore. Today, autonomous weapon systems are very real, and they're not just on the drawing board, they're on the battlefield. So let's dive into this complex new reality and see what happens when we give machines the power to make life or death decisions all on their own. So here's what we're going to cover. First, we'll look at the actual technology that exists right now. Then we'll explore how it's completely changing the nature of war. We'll also dig into some of the hidden costs to scientific research, tackle the huge problem of algorithmic bias, and finally, we'll look at the global debate on where exactly humanity should draw the line. All right, so let's jump right in with the state of play. This is not some far-off, distant future we're talking about. Major world powers have already committed to making these systems a core part of their armed forces. Some are even aiming to have their militaries majorly automated within this decade. Okay, just to make sure we're all on the same page, what exactly is an autonomous weapon system? Well, an AWS is a weapon that once a human gives it the green light, operates completely on its own. It can find a target, decide if it's the right target, and then take it out, all without any more human input. This is what people mean when they say human out of the loop. And look, this technology is already everywhere. In the air, you have what are called loitering munitions. Some people call them kamikaze drones that can actually hunt for specific targets, even individual people. On the ground, unmanned tanks are already seeing combat. Out at sea, you've got uncrewed submarines that can operate for weeks all by themselves. And it's not just the weapons. Even in the command center, AI is being used to analyze intel and suggest battlefield decisions to human commanders. It's happening across every single domain of warfare. So now let's talk about how this technology is changing the entire nature of conflict. Developing these weapons isn't just a tech upgrade, it fundamentally messes with the political and strategic calculations that lead countries to go to war in the first place. And that really brings us to the central question that's fueling this whole debate. Do these weapons actually make war safer? And the answer, as you can probably guess, is incredibly complicated. On the one hand, the promise seems pretty obvious, right? If you send a robot to fight, you aren't sending a person. That drastically cuts the risk of your own soldiers getting hurt or killed. But the peril is the flip side of that exact same coin. If the human cost of starting a war suddenly plummets, does that also lower the political barrier to starting one? And this is the absolute crucial point. When you take your own soldiers off the battlefield, you also take away a lot of the political heat that leaders get from their own citizens for using military force. This could make smaller-scale conflicts seem like a much more acceptable, almost easy option, and that could lead to a world with more frequent, maybe even constant warfare. Of course, any one of those small conflicts has the potential to spiral out of control into something much, much bigger. Now, moving beyond to the battlefield, this new kind of arms race has these really deep, often totally unseen consequences for scientists all over the world. It actually affects the very way that research and innovation happens. Right at the heart of this whole problem is something called dual-use technology. Think about it. The same AI breakthroughs that let a self-driving car navigate a busy street or let your phone recognize your face, well, those exact same algorithms can be repurposed for military targeting systems. This means that every step forward in civilian AI inadvertently helps fuel military AI, whether the scientists who created it ever intended that or not. So, a pretty natural question pops up then, right? Can't we just stop these weapons from spreading by controlling who gets access to the super advanced computer chips they need to work? It's an approach that's been used for other technologies, but with AI, it's not quite that simple. And this chart just illustrates the problem perfectly. The hardware needed to run a pretty sophisticated autonomous drone, something like the VBAT, requires about 100 TOPS of computing power. That's just a way to measure its performance. But the US export control threshold, which is the line for what's considered too powerful to sell to certain countries, is way up at 4,800 TOPS. That's 48 times higher. The chips you need for today's autonomous weapons are not even close to the cutting edge, which basically makes hardware bans ineffective. All of this creates a real chilling effect on science, which is supposed to be open and collaborative. You could see governments start restricting certain areas of AI research, all in the name of national security. You could see international projects get bogged down by visa bans for scientists. We're already seeing things like China's military-civil fusion model, where universities basically get pulled into military weapons programs. And even regular tech companies are facing more and more pressure to work on defense contracts, blurring that line between commercial and military tech. Okay, so let's talk about the software itself, the code. Because when we hand over lethal decisions to an algorithm, we are also, unfortunately, handing over our own deep-seated, very human flaws. When we talk about bias in AI, it's not just a simple technical glitch or a bug in the code. We're talking about systemic unfairness. It's when an AI system's performance is skewed in a way that creates different and often really harmful results for different groups of people, based on things like their race or gender. The AI isn't just making a mistake, it's basically acting as a mirror, reflecting and even amplifying the inequalities that already exist in our society. So where does this bias even come from? Well, it can creep in at pretty much every stage. It starts with the biases that already exist in society itself. That then gets baked into the data we collect and use to train the AI. And finally, bias can pop up in how the system is actually deployed and used in the real world, in ways the original designers might never have imagined. Let me give you a really concrete example. It's sometimes called the one-size-fits-men problem. Let's say you have an AI system that's designed to predict the blast radius and collateral damage of a weapon. If it was trained mostly on data that reflects the male body as the default, it could be dangerously wrong when it tries to calculate the harm a strike would cause to people with different body types. That could lead to a massive underestimation of civilian casualties. The data isn't neutral. It reflects a world often designed by and for a specific type of person. And the consequences of this, they are truly terrifying. A bias system might misidentify a target because it's learned to associate threats with certain racial stereotypes. It could cause disproportionate harm because it fails to account for, say, civilians with disabilities who might not react to a warning in the way the algorithm predicts. Or it could lead to discriminatory surveillance, where entire communities are watched more closely than others just because of their ethnicity or religion. So all of these huge risks, geopolitical, scientific, ethical, they've all led to this growing global movement that's demanding we do something. The question is no longer if we should regulate these weapons, but how. And this is not a new conversation. The push for regulation actually started over a decade ago with the campaign to stop killer robots. Since then, this idea of meaningful human control has become a really central idea. The UN started formal talks back in 2017, and just recently, we saw a major UN resolution in a call from over 60 countries, including the US and China, for the responsible use of AI in the military. You can see the momentum is clearly building. And you've got some heavy hitters weighing in. The International Committee of the Red Cross, they're basically the guardians of the laws of war, has taken a very, very clear stance. They are calling for new, legally binding rules that would include an outright ban on any autonomous system designed to target people directly. For them, that's a fundamental line you just don't cross. And they're not alone. Human Rights Watch, who helped start the whole Stop Killer Robots campaign, is saying pretty much the same thing. They're pushing for a new international treaty that would ban the most dangerous systems and strictly limit all the others, making sure that humans, and only humans, have meaningful control over life and death decisions. But then you have the official US policy, which, well, it uses some different language. The Department of Defense directive doesn't talk about a ban. Instead, it says that systems have to allow for appropriate levels of human judgment. Now, what does appropriate mean? That's a very flexible word, right? It suggests the level of human control could change depending on the situation, which is a very different thing from the outright bans that humanitarian groups are calling for. And that leaves us with the ultimate question, the one that really gets to the core of law, ethics, and morality. When an autonomous weapon kills someone, who's responsible? Is it the programmer who wrote the algorithm, the commander who deployed the machine, the company that built it? Or does responsibility itself just kind of disappear into the machine, leaving this dangerous gap where nobody can ever truly be held accountable?